Good day everyone, my name is Kathy C. Salazar and I am going to discuss the measurements of position and coefficient of variation as a measure of relative dispersion. So first is what are measurements of position. So while measures of central tendency and measures of dispersion are used often in assessment. There are other methods of describing data distribution such as using measures of position or location. So, what are these measures? This is quartile, decile, and percentile. First is quartile. So, in our discussion about the measure of central tendency, you learned that median of a distribution divides of data into two equal groups. Similar way, the quartiles are the three values that divide a test into four equal parts, with one-fourth of the data values in each part. That means about 25% of the data falls at or below the first quartile. And then 50% of the data falls at the below of the second quartile, and 75% falls at the below the third quartile. Notice that is also the median. We can also say that the quartile is the median of the first half of the values, and quartile 3 mark mark of the top whole of the class, while the lower quartile represent that of the bottom half of the class. So the concept were presented graphically in lesson. Is decile. So decile it divides the distribution into 10 equal parts. There are 9 deciles such that 10% of the distribution are equal or less than decile 1. So 20% of are equal or less than decile 2, and so on. So a student whose mark is below the first decile is said to belong as decile 1. A student whose mark is between the first and second deciles, it is decile 2. And one whose mark above the ninth decile belongs to the decile 10. If these are small number of data values, decile is not uh, appropriate to use. Percentile. So it divides the distributions into 100 equal parts in the same manner. For percentiles, these are 99 percentiles such that 1% of the scores are less than the first percentile. 2% of the scores are less than the second percentile, and so on. So, for example, if you scored 95 in a 100 item test and your percentile rank is 99, then that means that 99% of those who thought the test performed lower than you. This also means that you are belong to the top one of those who took the test. In many cases, percentiles are wrongly interpreted as percentage score. For example, 75% as a percentage score means you get 75 items correct out of 100 items, which is a mark or a grade reflecting performance level. But percentile is a measure of position. A lower score than you, or your score is located the upper 25%, the class who took the same percentage are commonly used in national assessment for university entrance examinations with large data set or scores in thousands. Part is what is coefficient of variation as a measure of relative dispersion. So you should note that the range, semi-interquartile range, or quartile deviation are standard deviations discussed earlier are expressed in units of original scores. Thus, They are measures of absolute dispersion. So let us say one distribution of test scores in mathematics may have a standard deviation of 10, and another distribution of scores in science may have a standard deviation of 5. If we went to compare the variability of the two distributions, can we say that distribution with standard deviation of 10 has twice the variability of the one with standard deviation? This measure relative dispersion is known as the coefficient of variation. This is simply the ratio of the standard deviation of a distribution and mean to the distribution. My insights is measures of precision gave us way to see where a certain data point or value falls in a sample or distribution. A measure can tell us whether a value is about the average or whether it's unusually high or low. Measures of position are used for quantitative data that falls on some numerical scale, and the coefficients of variation allows investors to determine how much mm, vo- va- volatility or risk is assumed in comparison to amount or of return expected from investments. The lower the ratio of the standard deviation to mean return, the better risk return trade off. So that's all. Thank you.